All right, you guys, we're on the next lesson, which is parallel lines and similar triangles. All right, so I'm on slide number 6. Let me see what we're going to be doing here. Okay, I got a triangle. Got some things I can click up here, but I'm not going to click anything until they tell me what to do. All right, question number 1. Check the box labeled show segment parallel to BC. All right, there it is. Okay, notice that DE intersects two sides of triangle ABC, creating a similar triangle ADE. Okay, so there's triangle ADE. All right, how is triangle ADE relate to triangle ABC? And how do you know? Well, if they're similar triangles, and it says they are similar triangles, that means they have congruent angles and their sides are proportional. That's the definition, you guys. How do you know? That's the definition. This is the definition of similar triangles. The sides going transversal. Yeah, so similar. No, that's not what they asked. All right, I'll go with it. Question number 2. What are the lengths of AD, DB, AE, and EC? Measure and record them. So I got to find AD, DB, AE, and EC. Okay, so AD first. So I'm up here into my angle icon and select distance or length, and I'm going to click on AD. I got 7.5. All right, next up is DB. So I'm going to click on DB. I got 18.5. All right, next up is AE. So I'm going to click on A, then E, 7.01. And EC, click on E, then C. I got 17.28. All right, that's all they asked me to do. Okay. Question 3. Find the ratio of AD to DB and the ratio of AE to EC. All right, so AD was 7.5. DB was 18.5. So I'm going to divide those two. 7.5 divided by 18.5. Okay, so I got a ratio of 0.41. Right, now I gotta do AE and EC. So AE was 7.01. Divide that by EC, which is 17.28. Oops, divide those. Divided by 17.28. All right, so also a 0.41 to 2 decimal places. Okay. So like I said, the sides are proportional. I set it up here in question 1. The sides are proportional, which means they come out to be the same proportion. I got 0.71 on both, rounded to 2 decimal places. Question 4. Now select point D and move it around. All right, let's do it. So I'm going to come over here to move D. I'm going to move it around. I'll put it right there. All right, you'll notice that DE moves with point D, but remains parallel to BC. So yeah, these definitely did remain parallel. All right, check the box labeled Show Ratios of Intersected Segments to show the ratios of AD to DB and AE to EC. Okay, so let's show ratios. All right, so it looks like the ratio is now 0.93 that I moved it. What do you notice about the ratios as you move point D? Well, they change, but they still remain equal to each other. So if I move it, they change, but they still stay equal. If I move it way down here, they change, but they still stay equal to each other. All right, so when you notice about the ratios, they remain the same ratio no matter where D is moved. Okay, the ratios remain equal. Awesome, that's what I got. All right, question 5. Now select B and C and move them around. Okay, so I'm going to select B and C and move it. There's B. Oh, look, these remain parallel. What if I move C way out here? Yes, so they still remain parallel. They still remain proportional to each other. What are they asking? All right, what do you notice about DE as you move B and C? It remains parallel. I just said that. DE remains parallel to BC. DE remains parallel to BC. All right, what do you notice about the ratios of the lengths of the intersected segments as you move them? They remain equal. All right, remains parallel. Awesome. And remain the same. Awesome. All right, nailed that one. Question 6. Based on your observations, what conclusion can you draw about the lengths of ADDB, AEBC? Well, I've already said it. They're proportional. ADDB. Let's move it back up here. ADDB, when I divide them, I get 0.41. AEEC, when I divide them, I get 0.41. So they remain proportional because they're the same ratio. I'm not sure what else I can say. It's asking the same question. Okay, so the ratios remain the same. Therefore, the triangles are proportional. What did they say? Ratios, in other words, lengths proportional. Y'all are killing me. All right, good. I'm not sure why they asked the same question, but all right, good deal. All right, question 7. Now check the boxes for show segment parallel to AC and show segment parallel to AB. All right, so show segment parallel to AC, show segment parallel to AB. That's an interesting looking figure. Find the ratio of BF to FC and the ratio of GB to AG. Then find the ratio of I to C to BI, and HC to AH. Right, what do you say about the relationship? Oh, good grief, people. They're going to remain proportional. All right, but I'll do it. Okay. BF to FC. All right, so you guys, I got to find the lengths of BF and FC. All right, so come over here to distance or length. BF, FC. All right, so it looks like I'm going to take, what did they say first? BF to FC. All right, so 13.95 divided by 3.5. So 13.95 divided by 3.5. Yeah, okay. All right, so let's divide that. 13.95 divided by 3.5. All right, so I'm getting roughly a 4. 3.98. I'm going to say 4. All right, so now that was BF to FC. All right, so let's see. Now I got to find X. GB to AG. GB GB, where's, all right, here it is, GB to AG. All right, so GB was 23.36, AG is 5.86. 2336 divided by 5.86. All right, well, let's divide those. 23.36 divided by 5.86, and it's roughly a 4. What did I tell you guys? They are going to remain proportional. All right, so let's see. All right, so I've got those. Then find the ratio of IC to BI. So IC to BI. Whoa, it's getting busy. Let me undo this. It's not going to let me, is it? All right, so let's do it. IC. Where's I? IC. Where's IC? Okay, IC to BI. Okay, so 13.1 divided by 4.35. 13.1 divided by 4.35. All right, let me come over here and divide this. 13.1 divided by 4.35. All right, this time that ratio is a 3. All right, what I gotta do now? HC and AH. HC. Where's HC? H. Oh, I can't see H. I gotta move that so I can see it. Whoa, I didn't mean to do that. I need to move this, not H. All right, so let's click distance H, C, and A, H. So HC is 25.26. And AH is 8.39. And I'm going to divide that. 25.26 divided by 8.39. All right, roughly get a 3. All right, so again, they're proportional to each other. So what can you say about the relationship? The sides are proportional. I don't understand why they don't believe me the first time when I say it. But over and over and over again, we're doing the same thing. All right, they're proportional. Bing, bing. All right, question 8. This is the last one. Yay! Based on your observation in question 7, what general conclusion can you draw about any line that is parallel to one side of a triangle and intersects the other two sides? Well, I've said it once. I'll say it again. Sides of similar triangles are proportional. All right, so there you go. Well, I guess we all know what you need to take away from this. Went through it 3 or 4 times. Sides of similar triangles are proportional. So there is slide 6, and I'm sure I'm going to have another one coming up. Hopefully they won't say the same thing over and over again there.